Welcome back to our Universal Canon of Literature series. I'm really excited about this next title. I discovered it back in college. I fell in love with the writer, but I'd like to make known at this point that I am no mathematician. I don't claim to be. Yes, I took the requisite number of higher mathematics courses in college and grad school. However, I do not claim to be a mathematician. These people are an island unto themselves. They're gifted in ways that the rest of us can only hope to fathom someday. The title is, in Latin, Disquisitiones Arithmeticae, which in English is Arithmetical Disquisitions. A title like that definitely is not going to make the top, Reader's Digest or the Time Magazine top seller, bestseller of the year award. But it doesn't have to worry about it because it's already a world classic. It came out in 1801 by Karl Friedrich Gauss. Now, Gauss is synonymous with mathematical genius. Let me explain. The three great mathematicians of all time, it is universally agreed, were Archimedes, the classical Greek period. That would have been the Hellenistic Greek period. Sir Isaac Newton, and Gauss, the one whom we are looking at right now. The first of these emphasized pure mathematics, that is, Archimedes. Newton stressed the applications to science. Gauss excelled in both pure and applied mathematics. For a famous statement, he called mathematics the queen of the sciences, and arithmetic the queen of mathematics. Gauss contributed to almost all fields of mathematics then known: complex numbers, infinite series, statistics, algebra, calculus, Non-Euclidean geometry, differential geometry, elliptic functions, astronomy, geodesy, electromagnetism. Sometimes geodesy is pronounced geodesy. And yes, I am reading from a book verbatim. This book is one of my favorites, the Thesaurus Book Digest, whose general editor, Chaim Haydn, will, in my personal opinion, go down as one of the greatest anthologists and editors of all time. But along the way, I am going to stop to explain some things. Let's look at, for instance, these mathematical fields with a little more depth. Obviously, complex numbers, infinite series, statistics. These are part of arithmetical operations in higher mathematics. Algebra needs no introduction. Calculus, which of course is divided roughly into integral calculus, differential equations, and of course you have other forms of calculus. Non-Euclidean geometries is those geometrical models that go beyond the elements of Euclid and all the geometricians, the geometers between Euclid and René Descartes. René Descartes, the great 17th century French mathematician, was the first to originate so-called non-Euclidean geometry. He is the father of coordinate geometry, also known as Cartesian geometry, analytic, a field which he termed analytic geometry. I'm going to continue, basically. Gauss was extraordinarily precocious as a boy, and his unusual ability remained with him through a long life. He lived from 1777 to 1855. That is a long life. It has been said that he was the last person to cover the whole field of mathematics. Now, as of the publication of this book, which was in 1951, was the last edition of this book from which I'm reading. Yet of all branches, there was one which was his favorite, arithmetic, or the theory of numbers. His mathematical diary is replete with discoveries of recondite theorems. Recondite, of course, meaning abstract, almost esoteric. One of 1796 was that every positive integer is a sum of 3 triangular numbers. Now, if you're a mathematician, that's pretty exciting stuff, because this young man was the first to discover it and expound on it. I'm going to read that again. His mathematical diary is replete with discoveries of recondite theorems, one of which, in 1796, was that every positive integer is a sum of 3 triangular numbers. Even then, at the age of 19, Gauss was planning his masterpiece, the Disquisitiones Arithmeticae, or Arithmetical Disquisitions. And this great work was completed 2 years later. A publisher's difficulties held it up until 1801. And Gauss, meanwhile, had printed his doctoral dissertation, definitely not idle. Even though his work has been held up, he's now printing, and he's finished up and is having published a dissertation in mathematics, of all things. Not just a paper, but a PhD dissertation in mathematics itself, higher mathematics, which he would have to defend before a committee of other mathematical scholars. So the first satisfactory proof of the fundamental theorem of algebra he was able to come out with in 1799. The Arithmetical Disquisitions is in 7 sections, of which the first 3 treat of the theory of congruences. The 4th is on the theory of quadratic residues, the 5th on binary quadratic forms, and the last 2 are on special topics in Diophantine analysis, including the construction of regular polygons. The work has been called, quote, a book of 7 seals, unquote, for it is difficult even for experts to read. Of course, the Book of 7 Seals is a tongue-in-cheek reference to the recondite and almost inexplicable nature of the Christian book of Revelations. In other words, except in the hands of the most committed and able of mathematical specialists, and even according to them, it's almost inexplicable. It's so complex. It is a work of art, having flawless perfection, and it exerted an immediate influence upon mathematics, raising higher arithmetic to a place on a par with algebra, analysis, and geometry. Gauss has hoped to publish a 2nd volume on arithmetic. He had hoped to. But in 1801, his interest was turned toward applied mathematics through the discovery of the planetoid Charis, or sometimes pronounced Ceres. A planetoid, of course, would correspond to our asteroid. He became director of the Göttingen Observatory in Germany, and astronomical problems preoccupied him for some time. His results were published in 1809 in a masterly treatise, Theoria et motus corporeum coelestium, which is Latin for the theory and means, and I'm translating this, the theory and means of the celestial bodies, in which he made use of his method of least squares. Through astronomy, Gauss was led to questions of geodesy and terrestrial magnetism, on which he published important memoirs from 1833 to 1846. He laid the foundation of the mathematical theory of electromagnetism. This is very important because about 30 years later, first Clerk Maxwell and then Max Planck would elaborate on this, not only through mathematical theory, but in the laboratory. They were the pioneers in the early works of electromagnetic theory. Quite simply, that work would not have been possible had it not been for this work by Gauss. He laid the foundation, as I said, of the mathematical theory of electromagnetism and constructed an electric telegraph. Pretty incredible. Gauss continued to contribute to mathematics, but he never returned wholeheartedly to his first love, arithmetic, to complete the Disquisitiones Arithmeticae. Nevertheless, this work remains the greatest of all works on the theory of numbers, the masterpiece of the prince of mathematicians. Yes, it's interesting that he was never able to complete his true love. If there is such thing as reincarnation, we can only hope that Gauss was able to return in some manifestation or another, perhaps as an obscure mathematician or mathematical student in some isolated university, or perhaps he's a scientist working a day, but hopefully he was able to, if there is such thing as a return to this life, complete his life's work, the work of his heart, which was not higher mathematics, such as calculus, but arithmetic, to which he opened up incredible new vistas. All right, thank you, and join us again when we look at the next title within the Universal Canon of Literature. Thank you.